Hello, my name is Tim Vogt. I'm a lead developer at Into the Source, and I've been developing software for 10 years right now. Basically now lead a team of 12 people who build software for a curtain company. And I was also involved with teaching people how to work with technology. And I used to teach kids with autism. I used to teach kids at Code Dojo, and I used to teach kids at every Friday in the public library. And I decided to scale this up a little bit because it was really intensive. I was a little bit frustrated I only could teach 12 kids at a time, and also adults have the same questions many of the times, but children usually ask really good questions. For this I also purchased some stuff which I can show here. That's a Cosmo I'm going to use which I'm teaching, and I've that one here. That's an EV3 of Lego, the old one. But I'm going to tell a little bit about that later. Basically, I want to discuss the technology right now. Technology is like a container speech for everything which is digital. And it could be, for example, your Google, it could be your iPhone, it could be your computer, your game console. Everything is digital nowadays. Even when you go to a parking meter, it's digital. But when you try to, like an onion, you try to peel off everything what's inside. What is the first step which operates it? How does it work? And how does it combine? And how does it talk to each other? For example, when you're loading a Fortnite game, how was it made? Who made it? How it is? Where is it stored? Where is it stored, and how does it come onto your PlayStation? How are you able to talk to other people? How is it possible that you have interactive people running around on your television? It sounds obvious, but there's a lot of logic and a lot of components doing this. And also when you're, for example, when you go to a parking meter, and you pay with your bank card, just bleep, digital. How does it, do they know to print a card? Where is the signal for the payment coming from? It's all connections with all, it seems so logical, but there's many things involved. For example, I built software for curtains, and you think like a curtain, software for a curtain, how complicated can it be? Now, imagine a curtain. You have like the flowing of the curtain. You have the length. You have like all really small seams and small adjustments and measurements. So it could be quite complicated if you you need like a really big stage curtain from ceiling until the floor, or like a small curtain for your dollhouse or something. There are many calculations and similarities involved. And also for a colleague of mine has now working for powering of cars, so you can charge your car. And when he started the company, he was like, okay, how difficult can it be to charge a car? And he discovered it can be quite difficult. You think it's just a card, you put on the loading, you put the loading in your car, and power flows into your car. It's easy, isn't it? But we technologists, we create this, so for us it's sometimes also incomprehensive and large, because we know what is underneath. Also, things struck my mind. Now Tesla's really involved with the machine learning and the self-driving car, but even Volvo has lots of components for this already, where when you go driving and you're a little bit off the lane, the car corrects it and goes back to the lane. And even small, when you have like the wipers, my Volvo has like automatic wiping. How does a Volvo know there's raindrops in front of my window and it goes slow, and there's more rain, it goes faster. There's all cool components we can investigate, and with this YouTube channel I'm going to investigate it. Basically what I try to reach this YouTube channel is make technology, explain what it does, make it easier, explain the components inside, do some experiments, investigate, and also do some coding stuff. That's all.